Excuse me. Hello, everyone. It's Julie Ray, and I am here to talk about box and whisker plot. While I'm sharing my screen with you, I'll let you know that box and whisker plots are some of my most favorite ways to share and analyze data. And that would be because they're a little bit mysterious when you first see them. But once you understand the how to read them and how to make them, they're actually very simple. They require very little in the way of math. If you can find an average of two numbers, you can make a box and whisker plot. So it is called a box and whisker plot, of course, because it looks like a box that has some whiskers growing out of the side. And that's where that strange name comes from. So let's dig into box and whisker plot. This problem actually came from a GED practice test. So let's see what it's asking us to do. Each player on the high school football team has been weighed, and the data are shown in the box and whisker plot below. So here's the box, here's the whiskers. What else is it that we're supposed to know about this? There are 5 important measures that you can see in each box and whisker plot, and they are usually marked by either usually by bars. Sometimes on the end you'll see a dot on the whisker, but that bar, this bar, this bar, that one, and that one are 5 key measures. And those are the important things to be looking at to get started and understanding what a box and whisker plot is measuring. So these 5 key measures come from a data set. All box plots, sometimes they're called a box plot and not box and whisker. All box plots start with the data set. And you'll notice that this is going to be about the box and whisker plot that I just showed you in the previous screen. This is the football player's weight in pounds. This is the player, just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I only did apparently half of the football team just to make this a little bit easier to deal with. And then these are the weights. So player 1, 170. Player 2, 184 pounds. Player 3, 200 pounds. Notice that this data is put in order. I'm not thinking that the players stood in line in order of weight. So you have to be sure that when you are working with data that you are using to make a box and whisker plot, the very first thing you do is put the data in order. So here we are in order from least amount all the way up to the greatest amount. Okay, now what? This is the same chart, the football player's weights in pounds, and this is the box and whisker plot that was in that problem that we saw at the very beginning. So look at this bar right here that I showed you as being an important part. This bar matches that data point. This bar matches that data point. This bar matches this data point. This bar matches that one. And finally, this bar matches that one. Now, if we look at this, just trying to get an idea of what is going on, we can see that one of the important data points is the minimum, or the least amount, the smallest weight. This data point over here is the maximum, or the greatest weight. So those are two very easy things to spot right off the bat. And then look at this one here. We count 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. We can see that this one is in the exact middle of the data set. So 5 numbers are less than this one. 5 numbers are greater than this one. That makes this number right here the median. Median and middle is the way I always remember it. It's the one with the D in the middle is the median. So those are the 5 key points, and that's where they come from. Notice that this didn't require any arithmetic. All I had to do was put the numbers in order and then sort out which is the least number, which is the greatest number. Easy peasy. Which is the median or the middle number. Also easy peasy. And then let's figure out where do these two numbers come from, and we've pretty much got the box and whisker plot sorted out. So remember we said this was the median. Oh, forgot what I was doing. Okay, this is the minimum. This is the maximum. This is the median of the entire data set. Okay, now let's see where those other two come from. If this is the median, notice that this is the lower half of the set, the one with the smaller half of the numbers, the least in value, these numbers over here. Notice that I could also find the median of this half of the data set, and that's what that point right there is. It's the median. There are 2 below, 2 above. This is the median of the first half of the data set. Its official name is called the lower quartile because it designates that 1/4 or 25% of the numbers are below that and 75% are above. Well, if this is the lower quartile, we can imagine what this might be called the upper quartile, and that's the median of the second half of the data set. So just looking at this half, not the rest of the data, just this half up here, you can see that this number is the middle of the data set. There are 2 below and 2 above. So those are the final 2 numbers that are important and when we're going to create and read a box and whisker plot. So we have the minimum, the lower quartile, the median, upper quartile, and the maximum. Notice that here's a really important point that 25% of the data is represented by this whisker. 25% of the data is represented by this half of the box. 25% of the data is represented by this half of the box. And 25% of the data is represented by this whisker. Now, these are not even divisions. Look how much longer this whisker is than that whisker. This half of the box is not equal to that half of the box, meaning in terms of size, it's not half, but in terms of the number of numbers that is represented by each part of the box, these are the same number of numbers here, the same number of numbers here. So This is a good example. The box and whisker plot is a good example of how spread out our data is. When we talk about mean, median, and mode, for example, those are called the measures of central tendency. That's their official name. They're telling us how close is our data together. Is it clumped together in one close pile? You think of a scatter plot where you've got a lot of X's on one number. How close are my numbers together? The box and whisker plot is really focused more on the range, how spread out our data is. But it can also tell us how close together it is. If our box and whisker plot was very short, very tight, we would know all of our data is clumped towards the middle. But something else a box and whisker plot doesn't tell us is how many numbers are there. Notice on my football team, I only had 11 members. But if you had Ohio State probably has 100 people playing on their football team. I don't really know. There's probably NCAA rules about that. But it doesn't tell me how many people are represented by this 25%. It just tells me whatever the total number is, 25% of that belongs from here to here. And 25% is contained from here to here. So if this part of the box is 25% and this part of the box is 25%, then together the box represents 50% of my total numbers that I have represented. In this case, 50% of my football players have weights that go between this number, 200, and this number, which is 240, I think I called it. So 50% of my players have weights between 200 and 240. Okay, so let's keep going and see what else we can find out about the box and whisker plot. So here is the question. In my way. Here is the question that came on that GED. It says, based on this box and whisker plot, which is still my football players with their weights in pounds, which of the following statements is accurate? So, does the heaviest player weigh 300 pounds? Well, here's 300. Is there anyone beyond that? Yep. This player right here. I'm going to call that 320. It's not marked, but that's about where it is. That's 320. So no, A cannot be right. The heaviest player weighs 320, not 300. Just because this is the last number mentioned, we have to do some interpretation and look to see that this point is beyond that number 300. So 1/4 of the players weigh less than 200 pounds. Let's look at 200. That is the lower quartile number. And we said that the quartile is 25%. If I go back a slide, we said that 25% is represented by this whisker. And here it is right here at 200. So go back. 1/4 of the players weigh less than 200 pounds. 1/4 is the equivalent of 25%. So yes, that seems like the right answer. What I know about a box and whisker plot is that each whisker represents 25% and my lower quartile is 200 right here, then that means that yes, 25% of the players weigh less than 200 pounds. Let's keep going though, just in case they're trying to trick us here. So, and maybe there's more than one true statement. The median player weighs 245 pounds. So remember, here's the median, the middle. It doesn't give us exactly what that number is. But if I'm looking at this, it looks like that's halfway between 200 and 250. So that means that my median is closer to 225. And if it was 245, it would be up here. In fact, it's quite possibly this upper quartile. So no, the median player weighs 225, not 245. So C is not the right answer. And then down here, the last one, choice D, says the lightest player weighs 200 pounds. 200 pounds is the marker for my lower quartile. So that is not the lightest player. The lightest player is this one, which is 170 pounds, more or less. So B would be the correct answer. Now, I liked this explanation that came with the GED question. It says the ability to interpret data from a box and whisker plot is a required skill for the GED math test. Here is the meaning of each part of the box and whisker plot, which we did all that. Minimum, lower quartile, median, upper quartile, maximum. And it says the minimum value represents the lightest player, the maximum value represents the heaviest player, median value is a player who is at the midpoint of the distribution, and the quartile values divide the distribution into fourths, which if we take just a minute to talk about quartile, notice that quart, we know that quart is a fourth of a gallon. We know that a quarter is a fourth of $1 or a fourth of a game. So a quartile is a segment of data that represents 1/4 of the data, and that makes sense. That's what we talked about earlier. So since the lower quartile is at 200, it is accurate to say that 1/4 of the players weigh less than 200 pounds. So if you need to, you can pause here and copy down this information so that you have your own picture of what a box and whisker plot means. So frequently, when we're looking at a 5-number summary, at a box and whisker plot, we are asked to figure out what is the 5-number summary. And those 5 key measures in the box and whisker plot that we talked about, that's what is being asked for in a 5-number summary. We're asked for the minimum, lower quartile, median, upper quartile, and the maximum. That is the 5-number summary. So here is another example of box and whisker plots. These box and whisker plots were drawn to analyze the data collected in a survey of scores for the doubles performances in the figure skating competitions at 2 Winter Olympic Games. Now, this is interesting because they've given us 2 box and whisker plots, sometimes called a double plot, and they're right on top of each other so that we can see how they compare. Look at this box and whisker plot compared to this one. The 2006 games have a much tighter spread than the 2010 game. So Another thing that's interesting to me about this particular plot is notice where this one starts. So it starts at 5, not at 0. The football team weight one did as well. It started at 150. So if you're creating your own box and whisker plot, you don't have to start at 1 and go up by 1. You can create it so that it makes sense to you as long as you use a reasonable scale and are consistent with your scale. So notice that this says the judges' scores down here, as soon as that little thing moves, the judges' scores are out of 10. So if you've ever watched skating, you know that 10 is a perfect score. So if you're in the Olympics, highly unlikely you'd get below a 6 anyway. I mean, you would have to fall down several times in order to get less than a 6. And people at the Olympics are usually better than that. So this makes sense. We've adapted the scale to fit what we need here. Now, let's see what else we would know about this. Which games were the scores, had the lowest scores? Well, we're going to compare these two minimums. Just without even looking at the numbers, we can see that this one is farther to the left, so this one has lower scores. Which one has the greater score? If we go over here, without even looking at the numbers, we can see that this is spread out farther. So that in 2010, someone had a very high score over here. What about the median? Again, this median for 2010 is farther to the right, so that's greater than the median for 2006. Look, finally we have something that's the same. The lower quartiles match. And then this upper quartile is less than this upper quartile. So if we were asked for the 5-number summary for 2006, remember it's the minimum, lower quartile, median, upper quartile, maximum. Those are the 5 numbers. And make sure you're looking at the correct one, because I know I got confused a couple times when I was working on this. So look at the minimum for 2006, the 5-number summary for 2006. It's this Goldie one here. The minimum, the lowest score is a 7. The lower quartile, we have to do a little bit of estimation here to try and figure out exactly where it is. I would say this is halfway, so I was calling this 7.7. You could convince me maybe it was 7.6. Anyway, it's 7.7. And then the median right on the 8. The upper quartile right here, a little bit past halfway, so 8.6. And then the maximum, not halfway, 9.2, what I called it. Okay, so those are the 5-number summary for 2006. What about for 2010? Let's look at those. 5-number summary, minimum, lower quartile, median, upper quartile, maximum. So the minimum for this 2010, not quite at halfway, so 6.4. The lower quartile matches that of 2006, 7.7. The median, halfway between 8 and 9, so 8.5. The upper quartile just past 9, so 9.1, and the maximum not quite at 10, 9.9. So in 2006, this is how we're going to use some of these, some of this information. These are some of the questions that you might be asked. In 2006, 50% of the scores were greater than what number? Well, which key measure are they asking us about? If 50% of the scores are greater than, remember that the median tells us the number in the middle, 50% are less than that number, and 50% are greater than that number. So it's the median that we're looking for. In 2006, what was the median? 8. In 2010, 50% of the scores were greater than, again, same question, where's the median in 2010? 8.5. Now, here's something else that we could ask. What is the range of scores? And we haven't talked about this except in general. The range of scores is the maximum number for 2006 minus the minimum number. And if we go to this maximum number, we call it 9.2, and subtract 7, 9.2 minus 7 is 2.2. If we go to 2010, 9.9 minus 6.4, the range is 3.5. And that makes sense because we see that these are more spread out, these 2010 scores are more spread out than the 2006 scores. So another question that you might be asked is, what is the range, or which set of data has a greater range? In this case, we would say 2010 because the data is more spread out. And we find the range by starting with the maximum and subtracting the minimum. We're looking for distance on the number line. We could also do it the other way as long as we took the absolute value. So which is more spread out is the question that is asked when we ask about range. So let's see how we might create a box and whisker plot. So this is that same football team. Notice we still have 11 players. And here are the team members. And then this is the number of hours that they worked out in 1 week, let's say. And so notice that I put the data in order. If it had been mixed up, the very first thing we would do is put it in order from least to greatest. Cannot work with box plot data unless we have our data in order from least to greatest. Notice that we've got some decimals. That's okay. No, although these are both 5/10, it could be anything. So let's see what happens. Remember, what is it that we're looking for? Our 5-number summary, which is minimum, lower quartile, median, upper quartile, maximum. So our minimum, we're finding it down here. It's our least number. So the least number of hours any team member worked out is 4. The lower, oops, nope, I don't want to do that next. I want to do the maximum because that's very obvious. I don't have to do much thinking about that. So what is the maximum? 18, the greatest number. And then the median, that's pretty easy to find too. Again, there are only 11 members on my team, so that I know whichever number is in the middle is the median. There are 5 numbers less than that and 5 numbers greater than that. And even though that there are 3 10s, that median number is still 10. So that becomes my median. Now I want to find the lower quartile. And remember that I find my lower quartile by looking at the lower half of the data. So that's where I'm going to go to find my median. I've got 1, 2, 3, 4, 5 numbers. So the one in the middle is my lower quartile. So 6 should be my lower quartile. Let's see. Share your phone. So if 6 is the number in the middle of this lower half of the data, let's see, 6 is our lower quartile. And then to find our upper quartile, we do the same thing. We go to the top half of our data and we find the median there, which is the number in the middle. It should be 12 because there are 2 below and 2 numbers above. Okay, so 12 is our upper quartile. Now, what do we do with those numbers? Well, again, I used Desmos, one of my favorite tools ever, and created this box plot. And I will show you next week how to use this and make your own. But for right now, we're just going to see where the data came from and how to interpret it. I think that's what you're most likely to be asked on the GED, not to create your own, but to be able to interpret it. And being able to understand and interpret the data is a really critical skill. Both parts are really important. So here's my minimum. That's not 4. There's that point. My lower quartile is 6. So I put a line here for my lower quartile. My median is 10, line here for the median. My upper quartile is 12, line for the upper quartile, and the maximum is 18. Remember that these 3 lines here, notice that they were drawn bigger to remind us to put a box around them because this represents the box part of our box and whisker plot, and then to connect the minimum to the box with a whisker and to connect the maximum to the box with a whisker. So just looking at this data, and this is one of the reasons I really like a box and whisker plot, is because it is visual. I can see how my data is spread out. I know that 25% of my players worked out 6 hours or less, between 6 and 4 hours. I know that 25% of my players worked out between 6 and 10 hours. That 25% of my players worked out between 10 and 12 hours. And 25% of my players worked out between 12 and 18 hours. So where is my data concentrated? I can see what's my range. My range is from 18, that's my maximum, down to 4, which is my minimum. And if I subtract 18 minus 4, I get 14. And that means if I divided 14 in half, that would be 7. I would expect my median to really be more like 11 if this was totally consistent. If my players were working out just about the same amount, that half would be below 7, half would be above 7, and so when in this case 11 because I started at 4. So this is telling me that my players are a little bit skewed this way, that more are skewed down here at the bottom. And then maybe there are some, this 25%, which is long. Remember, that's the same number of players. So it's really spread out. Let's go back and look at that data. I want to see. Or this is going up by 1, 1.5, 1.5, 2.5, 1.5, same, 1, 2, and then 3 and 3. There's kind of a jump here. So this tells me from 12 to 18, that's 6-hour spread. Whereas down here, the same, it's only 2-hour spread. So I've got more team members working down here below the lower half of my numbers. It's the same number of numbers, remember, but they're concentrated more down here. They're not having a lot of people working up in the 18 hours. That's really what do I want? Maybe I think 10 is just right. That's the number I'm asking. 2 hours a day, 5 days a week. These are the people who are doing exactly what I say. These are my overachievers. These are my underachievers. So what I really want is something that's more even. And that's what the data can tell us, is how even, and how evenly spread out and how much spread out our data are. So I think So that's the description of what a box and whisker plot can tell us and how to interpret it. And then next week, we'll do some drawing and some creating of the box and whisker plots, and you can see how to create your own. Sometimes creating your own helps you understand a little bit better what the data is telling you. So I hope this was helpful, and I'll see you next week.